Dear student, today we are going to start a new topic, that is characteristics of particles of matter. So what is the meaning of characteristics of particles of matter? Of course, matter is also a particle, but yes, any matter is made up of very small particles, very teeny particles. In last class I told you, even one drop of rainwater or any water drop, one drop is the combination of 10 to the power 21 particles of water. So I want to say the particles of matter, they are very teeny, and I want to use a term constituent particle. Okay, what is the meaning of constituent particle? Constituent particle means the particles from which any matter has been built or any matter has made. Okay, like if I talk about my building, my classroom, it is 5-floor building, and this building is made up of small bricks. Dear student, my building is very tall and very big, but this is made up of very small bricks, very small sand, okay, very small size of the cement and waters, but I constructed very tall building. Dear student, I want to say that any matter is made up of teeny particles, and yes, the most teeny particle possible about the matter, that is atom. Yes, I said in the last class that when atom and atom combine together, they form molecule. My dear student, there are two possibilities to combine the atom. Actually, if A plus A means atom plus atom combines, they form molecules, as you know. And I told you in the last class only that molecule size is bit bigger than the atomic size. Yeah, that is correct. But there are two possibility to combine. Possibility 1, both the atom are same type of atom. Okay, like oxygen and oxygen is combining together. Okay, so same type of atom. Second possibility is atom and atom will combine together. Yes, of course, both are very teeny particles, both are constituent particles, okay, of the matter. So two atom may combine together, but that two atom are two different type of atom. This two atom are two same type of atom. Okay, so sometime what may happen that X plus Y, can you see two different type of atom, and here can you see two same type of atom will combine together to form Z. Why I am saying that? Two different condition, same type of atom and different type of atom. What is the difference between them? As a molecule, this is also molecule, this is also molecule. Then what is the difference? The difference is, if two same type of atom will combine together, then molecule's property will resemble with the atom property. Molecule's property will be almost similar like atom's property. But when two different type of atoms will combine together, then the molecule formed, that molecule have very little property, very small resemblance in the property of the atom. Means I want to say that when two different type of atom combines together to form any matter, any compound, any molecule, that time property changes at large extent or totally changes. Okay, but when two same type of atom combines, that time property remains almost same, not 100%, almost same. Okay, so in this two way, what happens, atom plus atom plus atom plus atom plus atom, so many atoms can combine together to build a very big molecule, a very big matter. Dear student, I told you about my 5-floor building. This building is made up of very small bricks and sands, and I constructed very tall and very huge building. Okay, let me tell you about the very first point of the characteristics of properties of matter now. Dear student, the first point is the particles of matter are very small. Yes, my dear student, what happens, atoms are very small, very small. You can't see atom, and even with ordinary microscope also you cannot see the atom. It is very small, and yes, atom is the smallest particle in the universe. See, according to modern science, atom is not the smallest particle, okay, but in class 9th, in this chapter, till this chapter, yes, atom is the smallest particle, and from atom only, from the combination of atom only, molecule form, then compound forms, like that. So, the particle of matter are very small. I gave you example of my building also, and in last class I told you the example of raindrop, that one raindrop or one water drop contains 10 raised to 21 particles. Dear student, my dear student, this raindrop is very small already, and that also contains very teeny particle, very teeny particle. So, the summary part of my point number 1 is the particle of matter is very small, they are very teeny, and they, when they combine together, then only big matter can form. Guys, let me tell you the point number 2 now. Dear student, the particles of matter have spaces between them. Did you remember when you try to dissolve sugar in water, dear student, where it goes? After some time, sugar completely dissolves in the water, and before entering in the water, sugar was like in crystal form. Where it goes is a question. Why it disappears is a question. When you try to dissolve salt in the water, where salt goes? And when you try to dissolve sand in the water, then why sand is not disappearing is a question. If you answer this question, then you are able to understand the point number 2. The particles of matter have spaces between them. What does it mean? Okay, one more thing, dear student. You know that when you dissolve sugar in water, sugar will disappear. I understood that. And what happens when you dissolve sugar with any other solid eatable matter, like when you try to, did you ever try to dissolve the sugar and any other solid eatable matter like sugar and rice? Okay, not cooked rice, no, it's raw rice. Did you ever try to dissolve that? It's not possible, my dear student. It's not possible. Now, let me explain you the point number 2. Okay, the particles of matter have spaces between them. Dear student, what happens actually if you talk about the small layer of water, like this is my tub, okay, and in tub this is the level of the water, okay. So, what happens till this layer we have water here, right. Now, in water what happens, gaps are there. In water gaps are there. Even in ice also there is a cage like structure. Ice has internally, in the ice it has cage like structure, and in that cage few things can be captured. Yes, dear student, in that ice cage what happens, few things can be captured. There is a space, vacant space. In same way, dear student, this liquid, this water, it has also spaces, empty spaces where anything can stay, can fit there. Okay. So, now I am answering my question only, that where the sugar goes, where salt goes, and why not sand is disappearing. Now, let me answer that. What happens, whatever the free space, the empty space inside the water is there, our sugar or our sand goes and fits there. So, that sugar is inside the water, inside that empty space present in the water, or my salt is inside the water in that empty space. So, the particles of matter have spaces between them, whether it is solid, liquid or gas, does not matter. All the types of states, all the states of matter, they have the space, a vacant space, all these 3 types. Dear student, normally in till class 9 we have only 5 states of matter, that is solid, liquid, gas, plasma and Bose condensate. Okay, I will definitely explain all one by one, but not in this lecture. This lecture is about to tell you the characteristics of particles of matter like atoms or molecules. Okay, so the particle of matter have spaces between them. How do you know that? What is the practical observation? So, the practical observation is try to dissolve the salt or sugar in the water. You will understand, yes, they have spaces. Now, one more question. Why sand is not fitting inside that water space? What happened with the sand? Dear student, this answer is in class 12 in solution chapter. What happens? There the rule is like dissolves like. The rule is what? Like dissolves like. What is the meaning of like dissolves like? Like dissolves like means, if you are, means if this is my institute of science, then arts student will not come. Only science student will come here. Only chemistry student will come here. Okay, economics student will not come here because I don't teach economics. Okay. So, what happens like dissolves like actually, because I am a chemistry teacher and you are a chemistry student, that is why we dissolved, we merged together and you are studying and I am teaching. But if you do not want to study economics, you do not want to study math suppose, then you will not go to maths teacher and you will not merge there, you will not take admission there. So, in the same way what happens like dissolves like is the answer that why sand is not able to dissolve in the water, and this complete answer I will explain in class 12. This is from there. Okay. So, today in point number 2, if I want to summarize, I will say that all the states of matter like solid, liquid, gas, they have vacant space, they have empty space, they have free space, and yes, there few things can live, can fit there, like ice has cage structure inside, and all the liquid has also free space, where the solute particles, I mean the sands, the NaCl means salts and sugars can fit there, can live there. Let me tell you about the point number 3 now. Dear student, the particles of matter are constantly moving. What does it mean? Have you ever seen that if you kept marker here? Have you ever seen that if I kept marker here, then marker will start move? No, never. Okay. Once you try, you can just put one glass of water on the floor. That water will move, no doubt. Okay. Or if you keep open any gas container, that gas will move, possible. But have you ever seen that any solid material is moving? Is this marker moving, this solid material? No. Is this board moving? No. Means, have you ever seen that your bench or desk starts moving? No. Okay. Then why I am saying that particles of matter are constantly moving? What does it mean, my dear student? Let me explain you. Now, you go to that type of building which is 100 years old, 200 years old, like that. Okay. Just try to visit that building. Now, what you try to observe there, you go to the glass, window glass. Okay. Window has glasses na. So, you go to that glass and you observe that 200 years old glass or 100 years old glass. Just observe that. What will be the observation is that you just try to look at the thickness of the glass, whole glass. Suppose glass is 3 feet, okay. Look whole the 3 feet. What observation will come, my dear student? Glass thickness will increase slowly. How? Means it will be something like this. Like this, dear student. In the beginning, it will be very thinner, thick. Okay. So, what happens actually? In the beginning, 200 years ago or 100 years ago, what happened actually when they applied the glass there in the window? That time it was simply like this. Like this only. Okay. But what happened? Years, so many years completed past, 20 years, 50 years, 80 years, 100 years. Then what happened, my dear student? Because solid has fluidity, but the rate is very slow. So, what happened? Whatever the constituent particles, the materials inside the glass, they started moving towards down, because downward what happens? Gravity works, downward mg works. Okay. So, this glass material starts moving down due to its gravity, and slowly it moves. Its rate of movement is very slow. That is why we can't observe that marker is moving, but yes, marker is moving 100%. Marker is moving. Okay. So, what happens actually in the glass? Means this is one example, very normal example, what you can observe in old buildings, that the thickness of glass in the very beginning, the very first day when they applied the glass, that time it was simply like this when it was very new. After 100 years, 200 years, it is like this. The thickness of glass is increasing, my dear student. Okay. So, yes, solid has fluidity, and of course, liquid and gas has also fluidity. So, solid, liquid, gas all can flow, but solid fluidity rate is very low. Dear student, in gases the fluidity rate is very high. then in liquid, and then in solid. So, with the point number 3, if I want to summarize, I will say that all the 3 states of matter, they have fluidity. Yes, they flow, where the solid has least rate of fluidity. Now, let me introduce here point number 4 now. Dear student, the particles of matter attract each other. What does it mean? Have you ever seen that this marker and one more marker, are they attracting? No. Then why I am saying like this? Why I am saying that particles of matter attract each other? Okay, just have you did you remember that the gravitational law? What Newton said in his gravitational law? Okay, if you didn't remember, no problem. Let me explain the 4th point now, that how particles of matter attract each other. Okay, what happens actually? Any matter, okay, that may have small size, may have big size, very large size. Okay, like one small room has small size, but one very big building has very big size. Okay, so what I want to say is, all the particle in this universe, Newton says in his theory that all the particle in this universe, they attract each other. I am attracting some other material, that material attracting me. Okay, means this earth is attracting sun, sun is attracting, means everything in the universe attracting each other. Yes, and on the basis of this theory only, I hope this theory you will study in your physics, not in chemistry. So, the particles of matter attract each other, but the reason is why they attract each other is a question. Why they attract each other? So, my dear student, what happens actually, in all the particles there is a positive charge and there is a negative charge. If two body attracts, it is not necessary that always two body will attract. Sometime what happens, attraction and repulsion both takes place, where repulsion force is more than the attraction force. Two bodies there. Okay, and if you are not able to observe that they are not attracting, it means that, it does not mean attraction force is not there, it means that attraction force is less and repulsion force is more. But yes, all the body attracts each other. Now question is, why it attracts? The answer is, all the body contains positive charge also and negative charge also. So, positive of this body may be attract with the negative of other body. This is the reason. Opposite charge is one reason to attract, but there are so many reasons, but here in class 9 we discuss very simple reason, and that is one reason only. Maybe in one body positive charge is there, in other body negative charge is there, and they attract together. This is the real reason to attract together. So, I explained 4 points in the characteristic of particles of matter, my dear student. It completes this topic. Thank you.